Here is a combined summary of the 4 pages. Blind individuals face significant barriers in participating in data stewardship processes, particularly when sharing image data captured using AI-infused applications. This study explores the decision-making processes of blind individuals when sharing their image data, situated within a larger cross-sectional study on participatory data stewarding processes. The research deployed a teachable object recognizer and co-designed an accessible data sharing system, AccessShare, with blind participants. AccessShare facilitates interactive informed consent and enables communication between data stewards and blind data contributors. The system incorporates automatically generated descriptors to assist blind users in assessing photo contents, with set-level descriptors providing summary information on characteristics such as image quality and hand presence. The findings highlight the importance of balancing sighted help and self-reliance in decision-making and the need for data inspection systems like AccessShare to facilitate communication. The study contributes empirical findings from a real-world participatory data stewarding process, reflecting on decisions formed and communicated. It also introduces AccessShare as a probe for co-designing accessible data sharing systems that facilitate control among blind data contributors. The research informs future work on involving underrepresented communities in discussions around informed data sharing consents and meaningful data inspection and control, building upon recent, disability-first, data collection efforts. The co-design session involved 10 blind participants evaluating an object recognition app deployed on smartglasses, capturing photos of everyday objects and labeling them for model training. The findings emphasize the importance of data access and sharing models that prioritize the needs and expectations of blind data contributors. The AccessShare project is a collaborative effort aimed at co-designing data access and sharing with blind individuals, focusing on providing them with control over their study data. A multi-day study was conducted involving 13 participants recruited through various channels. The study protocol was approved by the institution's review board. The participants underwent a 30-minute Zoom call to capture demographics, attitudes, and technology experience, followed by a system evaluation from their homes, where they evaluated a teachable object recognition app deployed on smartglasses. They took photos and provided labels for training and evaluating a computer vision model. After the system evaluation, participants joined a remote semi-structured interview to reflect on their motivations and concerns related to sharing their study data. They were then invited to a follow-up co-design session to design together ways for blind data contributors to access and control their data. In the co-design session, participants received an email with a unique link to AccessShare, where they could access their own set of photos organized by labels. They were encouraged to explore the interface and provide feedback on their experience. The co-design activities consisted of 2 parts: hands-on interface exploration and discussion with guiding questions. Participants were asked to explore AccessShare, find a specific object label, read a summary content, and describe the first 3 photos on the page. They then discussed their experience accessing their data, reflecting on what was helpful, what was missing, and potential improvements and features. The guiding questions covered alternative methods, descriptors, trade-offs, and potential features and capabilities. The analysis of the co-design session involved triangulating data from various sources, including recordings, offline communication of participants' decisions around data sharing, and manual annotation of personally identifiable information, (P), in the photos. The participant feedback was transcribed and analyzed using inductive thematic analysis, where initial descriptive codes were assigned and then interpreted and categorized. The themes and subthemes were refined through team discussions to conceptualize them as unifying concepts. The study's findings will provide insights into how blind participants sought access and control over their study data and how their decisions were shaped in the process. The results will inform the development of accessible data inspection methods and features that cater to the needs of blind data contributors. In the study, the researchers also explored participants' decisions on sharing their study data, including photos of objects and labels. The majority of participants decided to share their data, citing the absence of concerning elements in the photos. Some participants employed privacy strategies during data collection, such as capturing photos with caution, to ensure comfort with sharing. Others were motivated to contribute to research, despite some initially expressing concerns about privacy. A heat map was used to provide context on PE across participants' photos. The researchers found that participants' decisions to share or not share their data were often influenced by the perceived value of their study data, with some expressing concerns about the quality of their photos. Interestingly, participants' willingness to share was also impacted by the perceived value of their study data, with some referring to their photos as good or bad. The study highlights the importance of considering the unique perspectives and needs of blind data contributors when constructing datasets representing the blind community. The researchers also examined how participants formed and communicated their decisions, finding that some participants indicated their decision informally during the interview study, while others provided written consent or verbal consent during the co-design session. The study suggests that email may not be an effective approach for obtaining written consents from blind data contributors, highlighting the need for alternative methods. The co-design of data access and sharing with blind people requires a nuanced approach, prioritizing informed consent and meaningful data control. AccessShare, a novel interface, facilitated interactive consent, allowing participants to engage in dialogue with researchers to discuss potentially concerning elements in their study data. This approach enabled participants to solidify their decisions and concerns. Blind participants preferred verbal consent during study sessions after data collection, valuing the opportunity to discuss concerns with researchers. However, power imbalances between participants and researchers pose challenges. Establishing and communicating alternatives with potential data contributors is crucial, and researchers must be aware of the potential for persuasion or coercion. The study highlights the need for a delicate balance between independence and support in data sharing platforms. Participants sought a balance between self-reliance and seeking cited help, expressing concerns about relying on available and trusted cited help. Incorporating commenting features for each photo, and having a dedicated person for data collection and management, could be beneficial. Enhancing data descriptors and inspection methods is also essential. Participants suggested integrating AI-infused capabilities, such as alt text captioning and text recognition, to improve photo descriptions and support their need to inspect for potential concerns. Verbosity controls, including checkboxes and settings or hierarchical approaches, can provide detailed descriptions. The study underscores the importance of acknowledging the negotiation process between blind and sighted users in multi-user data access. Revisiting the concept of consent as a shared multi-user decision may be necessary, and addressing power dynamics and potential misuse is crucial. By prioritizing interactive consent, independence, and support, data sharing platforms can better serve the needs of blind individuals. This study presents a co-design approach that engages 10 blind individuals in real-world data stewarding, using a novel interface called AccessShare to facilitate participation in consent, data inspection, and control. The findings highlight the importance of interactive consent and the complementary nature of AccessShare in fostering communication between data stewards and blind data contributors. Design opportunities for data inspection and control are discussed, along with limitations and future challenges in data sharing and privacy concerns. The study reveals that blind participants prefer an active role in data sharing, with varying levels of agency among users, and emphasizes the need to balance privacy and data sharing. Ongoing reassessment and consent in data sharing practices are necessary, as well as addressing value gaps between data stewards and data contributors. Co-developing approaches with blind people is crucial for ensuring meaningful privacy control in assistive smart devices. This research also co-designs data access and sharing with blind people, focusing on the intersection of accessibility, privacy, and artificial intelligence. The authors propose a novel framework for co-designing AI systems with blind people, focusing on data sharing, accessibility, and privacy. Involving blind people in the design process can lead to more inclusive, accessible, and respectful AI systems. The paper explores data cooperatives as a means to promote autonomy and agency for individuals with disabilities. Key limitations of the study include its small sample size and potential biases. Future work should focus on integrating participant consent and feedback into data sharing practices, considering the potential for an order effect on consent options presented to participants. The research emphasizes the need for ongoing research in this area, including the development of data cooperatives and dual-purpose systems for data inspection and sharing.